Hello everyone. My name is Sudheer Dantuluri. I've been working as a software engineer in the Microsoft SMB team for the past 2.5 years. I have a master's in computer science from Texas A&M University and a bachelor's in computer science engineering from IIIT Hyderabad. Along with me today, my colleague Thomas Salemy will be speaking on this topic. Thomas, you wanted to do a brief intro of yourself?
Yeah. Hi, everybody. My name is Thomas. I am a newer software engineer here at Microsoft, but I spent many years in a research lab during my undergrad working on many concepts across distributed systems. And I'm excited to present SMB over QUIC with Sudheer today.
Thank you, Thomas. Let's get started. So we'll be speaking on the topic SMB over QUIC. This feature enables us to access files on the remote file system without the need for having a VPN connection. This is our agenda for today. We'll start with a brief overview of what QUIC is, and then get into the motivation of why we wanted to try SMB over QUIC. Later, we'll get into the details of how we integrated the QUIC transport into the current SMB architecture, and then talk about the management story. And after that, Thomas will be talking, discussing the SMB over QUIC performance details, and we'll conclude with a short demo. So QUIC is a new networking transport protocol originally proposed by Google. It works on top of UDP. It was developed by taking some of the best in-class features from HTTP2, TLS, and TCP. So it forms the basis for HTTP3. QUIC allows for faster connection setup, like it provides one round trip time for initial connections and 0 RTT for resumed connections. So QUIC has this concept of a session. A session basically encapsulates the application layer protocol negotiation, which is the application layer protocol, the TLS state, as well as some of these other things such as silos and network compartments. And each session can have one or more connections. And since the session encapsulates the TLS state, once the initial connection is established, even after you close the connection and try and reopen the connection using the same session, because the TLS state is already cached, it allows for 0 RTT for subsequent connections, as well as if you have more than one connection. That's where this caching of the TLS state within the session helps. And QUIC also provides for better security, like with TLS 1.3, it provides for mutual authentication, but both client and server can authenticate the other. And it also mitigates man-in-the-middle attacks, as most of the packet is encrypted. Once your traffic is flowing through QUIC, you can ensure yourself that nobody's gonna ever eavesdrop into your packet, or nobody's ever gonna to tamper with your packet. So it provides both privacy as well as the integrity of your network traffic. And following are the few of the improvements that QUIC provides over HTTP2 and TCP. And one of the primary benefits is no head-of-the-line blocking. So as I mentioned earlier, there's this concept of a session in QUIC, and within the session, you can have one or more connections. And within each connection, you can have one or more streams, and each stream can be bidirectional or unistream. And these streams can be multiplexed. So if you have a large packet and a few smaller packets, because of this multiplexing, your smaller packets don't have to be blocked until your larger packet is delivered. QUIC also provides for better transitions between networks. Once a QUIC connection is established, you can set parameters such as local address and remote address on the connection throughout the lifetime of the connection, and the rebinding will automatically happen. So QUIC allows for connection migration this way from cellular to Wi-Fi or vice versa. QUIC also has better loss recovery mechanism compared to the other transports. Per my knowledge, it allows up to 256 selective ACK blocks in comparison to TCP, which has around 3 or 4, I believe. And QUIC also doesn't have this retransmission ambiguity because it uses a monotonically increasing packet number, and every packet is a new packet. So even if there's a retransmission that is required, it sends it as a new packet rather than using the existing sequence numbers like the other protocols. And QUIC being relatively recently developed, it has the benefit of using the latest congestion control algorithms. And it allows for better portability and agility, being on UDP and also being available for both user mode. You have the benefit of easier deployments. And QUIC, though originally proposed by Google, it is being standardized by IETF. So it has the benefit of contributions from all the parties that are interested in the protocol. And here is a diagrammatic representation of QUIC optimizes the handshake process. In the section A, the diagram show the handshake for initial connections. And in the section B, you see the diagrams for resumed connections, where the TLS state is already cached. With TLS 1.2, you have 3 RTT. When you use TLS on top of TCP, you have the TCP handshake and the couple of handshakes from TLS side before data transfer can begin. And TLS 1.3 has optimized the TLS handshake. So you have one handshake for one RTT for TCP and one RTT for TLS. So that comes out to be 2 RTT before data transfer can begin. Since QUIC does it all together, it gets 1 RTT before data can be transferred. And in the section B, like once the initial connection has been established, because the TLS state is already cached, you reduce 1 RTT in each of the 3 cases. And that's where the reduction of RTT happens. Now let's go into details of why we wanted to try SMB over QUIC. SMB traditionally used to work on TCP, and it uses port 445. And though it is in widespread use within the enterprise, across the enterprise, it doesn't usually work because ISPs often block port 445 with lots of legacy Windows machines all over the internet, and probably some of them not very secure. They wanted to minimize the attack surface. So ISPs often block 445. So that results in not being able to use the feature across the internet. And if at all you wanted to use it over the internet, you need to have a VPN connection to be able to access these resources. So we wanted to address this problem. And with QUIC, we could address it, and we'll get into details of how we make use of it. A short discussion on the advantages that QUIC provides for SMB. One thing is it avoids server spoofing. QUIC has this mechanism of using certificates to authenticate the identity of the server. When a client tries to attempt a QUIC connection, the server is required to present a server certificate that is as a proof of its identity. And on the server side, this server certificate is sent to the client And within the client QUIC layer, the validation of the certificate happens, whether the subject names matches the secure principal name of the server. Is the certificate still valid and is not expired? Does the certificate actually route back to the client's trusted root chain? So all these validations happen at the client side, and this way, even if your DNS cache is poisoned or someone is spoofing the DNS, you can still ensure that you're not talking to you can ensure that you're talking to the right server. And QUIC connect, another benefit that QUIC provides SMB is QUIC connection is always protected by TLS 1.3 encryption. Right from the word go, the channel is completely encrypted. All the traffic is encrypted, and this doesn't even happen with SMB encryption and as well. And we wanted to use SMB over QUIC because when port 445 is blocked, we expect we can still connect to the remote file system using QUIC and over UDP port 443. And one of the data points that we have from Google experiments is that there was a 93% connection success rate when connecting to port 443. And Microsoft QUIC implementation allows multiplexing of multiple protocols on top of UDP port 443 because it can differentiate different protocols like HTTP and SMB, though they are using the same port 443 using the application protocol negotiation field, which is inside the session layer. It is, for example, it is SMB for SMB, and it can be something else for HTTP, like say HQ or something. There are a few downsides as well. Currently, we see a poorer perf with QUIC compared to even SMB with SMB encryption turned on. And currently, there is no hardware offload support for QUIC, but this is bound to change over a period of time. And in future, we may get better hardware offload support for QUIC as well. And another problem is the Kerberos authentication protocol cannot be used without means to reach KDC from the client. So the authentication defaults to NTLM, which is a slightly weaker authentication protocol. But you still have the advantage of QUIC encryption because even the NTLM exchanges are tunneled inside the TLS 1.3 connection. And another another thing is the TLS encryption is machine to machine rather than user to machine. In case of SMB encryption, it is user to machine, whereas TLS encryption is common for all the users on a machine. So there is something that is shared between all the users on the machine. Getting into the integration. So this is a high-level architecture of how SMB SMB components work. On the top, there is an application which is trying to access a remote file system or a remote resource, and SMB client claims a request. It has a bunch of functionalities such as multi-channel signing, encryption, and compression, and it does its work and then hands it over to the transport layer. So currently we have a bunch of transport layer protocols that is supported by SMB. There are this legacy transport direct interface on the WinSock kernel that work over TCP, and there is SMB direct which works over RDMA, and from there the traffic goes into the NIC and to the server end, and all the things happen in a reverse direction at the server. From the transport, it's handed over to the SMB server, where all the SMB functionality happens, and then it queries the local file system and gets the data. Now, alongside these other protocols like TCP and SMBD, now we are adding QUIC. And we get all the QUIC functionalities that QUIC provide along with this. And with SMB or QUIC, we wanted to discuss what all is changing. But all of the SMB features still remain the same. Like there is no difference. SMB will still establish multiple connections to scale this CPU. And so there is absolutely no difference with respect to multi-channel. And we don't use SMB signing and encryption by default because QUIC already provides that for us. And in addition, SMB over QUIC will be using the server certificate on the when QUIC is used as a transport to make sure there is no server spoofing attack. And SMB authentication works the normal way. On the server side, we use only a single session, a single QUIC session. And with respect to SMB encryption, by default, the client and server exchange and during negotiation, they negotiate that they agree to use the transport layer encryption. And this tells the SMB client and server to not do SMB encryption even when the share is marked encrypted. So by default, they accept the encryption that the transport provides. And there are flags to override if at all users wanted to use the SMB encryption on top of QUIC encryption. A workflow of how this works. First, client tries to open a server name and a share. Then the name resolution happens. Client fires parallel connection attempts to TCP and QUIC. Currently, TCP is given a little bit of a head start. And whoever wins will claim the connection, and then the interfaces, client will query the interface information from the server and multi-channel will kick in. And then the traffic is exchanged between the client and server. And so the bottom line is both TCP and QUIC are attempted, and whichever succeeds first will be taken. On the server side, servers will start all the listeners on UDP port 443. When it gets a connection request, it finds the certificate for the new QUIC connection and provides it to the QUIC layer and accepts the connection. And then the exchange starts. So server starts both TCP and QUIC listeners by default. But then if we want to configure it such a way that you want to start only TCP listeners, that's also possible. Let's get into the details of the certificate management. The SMB server supports multiple secure principal names. By default, it assumes that there are no such certificates associated with the principal names. Like the system can have multiple certificates, but then you still have to make the SMB server aware of, you have to tell the SMB server to use the specific certificate for use for the QUIC communication. So this is done through the Powershell commandlets, the management utilities that we developed. Using this PowerShell, we instruct the SMB server to use a specific certificate for as its identity for the communication over QUIC. So, new SMB server certificate tells the SMB server to use a specific certificate for communication over QUIC, and remove SMB server certificate removes that certificate, and get SMB server certificate mapping will give the list of certificates on the system that are registered for use by SMB server for communication over QUIC. And a bunch of new properties that we added. Enable SMB QUIC to turn on or turn off QUIC listeners. Disable SMB encryption on secure connection. This is on by default because when QUIC by itself provides encryption, you wanted to make sure of make use of it and avoid a double encryption. And there's a restrict named pipe access by QUIC. Since we are developing this as an internet feature, we wanted to restrict, since RPC over named pipes happens over SMB, we wanted to restrict the management to within enterprise, and however, the usage can have, the data transfer can happen still over the internet. So this is off by, the restriction is on by default, though optionally it could be turned on if users prefer that. Some management story on the client side as well. So now you can create an SMB mapping by specifying the transport type that you wanted to use. Like you can specify, create an SMB mapping by specifying transport type as QUIC, in which case the server certification is completely validated on the client side. All the validations that I mentioned earlier, whether the certificate has a proper subject name, whether it's still valid and it's not expired, whether it root backs to the client's trusted root chain and stuff like that. There is an additional option called skip certificate check, which completely drops validation altogether. Like whatever certificate the server provides, that is still accepted. So absolutely there is no validation when this option is provided. So it's definitely not recommended for internet facing servers, and is only recommended for within enterprise use. And in spite of this option, though you don't get server spoofing, you still get a secure channel. And there is this get SMB mapping, which lists the properties on the mapping, and alongside other properties, you get the transport type on which this mapping was established. A couple of configuration options on the client as well. One is whether you wanted to force SMB encryption on top of QUIC, and second is the skip certificate check. And this is a machine-wide property. So for all the mappings to all the servers, certification validation will be dropped off if you turn this flag on. A couple of recommendations on the certificate usage is to avoid using self-signed certificates and to use certificates that are issued by a trusted authority. And with that, I'll hand over to Thomas. You want to just start talking about performance?
Yes, thank you for providing that very detailed overview and integration. So when planning and framing performance, you should always start with the following, that is defining the purpose of what you are stress testing. So we have a story for why QUIC is so important, which is that we're expanding SMB and moving its battle-tested stack into the public internet, which is a more ubiquitous place to transfer information and one where many of our applications do run. But for the enterprise, we must make sure, even though we know every new technology in its immature stage is likely inferior to its former predecessor, that QUIC performs well enough to the current state of the art. And the current state of the art is SMB encryption with TCP. And so from here, now that we've defined what we want to compare QUIC against, we'll go into defining the workload that we tested against, defining the path dependencies, and why we remove them, and collecting the correct traces and displaying those results to you. So starting with the workload, we did sequential read. I'll get into that in a second of why. And then really quickly on the storage side, we actually virtualized our storage with an internal tool and removed that as a potential bottleneck that would impair performance, and made going to disk negligible, again, through internal tools. Next, and so yeah, you can see here, right, but these numbers without context in comparison to TCP might not make sense, but yeah, next slide. So yeah, here is the most important slide as it relates to performance. So again, we're comparing QUIC against TCP with SMB encryption turned on, and looking at the throughput kilobytes per second on the y-axis. And as you can see, QUIC does a good job matching TCP with encryption turned on when it relates to a single core, but as we, and we'll get to this in a second, is that its scaling ability is constrained because QUIC in its current state in SMB was developed for a single core. And what will explain this trend that we see here is the next slide, is a flame graph. So yeah, so you can see that SMB TCP with encryption, we're spreading our compute and offloading it across many different cores. And again, this is because we have been using TCP for a long time, and have developed SMB with this in mind to optimize performance as much as possible. So again, we see that compute is spreaded across many different cores. Next slide. On the other case, QUIC, just as of today, only really for a single connection is pinned to a single core. So as a consequence, again, as we saw in that first graph, we do a good job of matching TCP performance when we have a small enough packet size, as well as only, again, using a single connection. But SMB does not scale as well simply because we are not expanding to more cores. And so we have reported this to the Microsoft team spearheading this effort. But again, SMB over QUIC does a good job for that initial very common use case, 4 kilobytes with a 512 queue depth. So that is the main story around performance.
Thank you, Thomas. And let's now play a demo video. So here we tried to access an Azure VM, a share on an Azure VM using TCP first, and observe that it doesn't succeed, and then we'll try QUIC. So here is the first attempt. Just trying to connect. Yeah, it shows a dialog as if the authentication did not get through, but in reality, the connection is not getting through. Now we'll try QUIC. There you go. You can successfully establish a connection and view files on the Azure VM. And on the Wireshark capture, you can see traffic flowing over QUIC and UDP port 443. It's by opening a couple of files and seeing the data. So it's since all the packet data is encrypted, you don't, Wireshark then couldn't figure out that it's actually SMB2 traffic. And we play another demo where we play around with net use with different transports. We have a server that blocks TCP/4.5. We have a firewall rule enabled, and it blocks any inbound traffic over 445. We have an SMB QUIC share on the server, and the server is VM6. We'll try to connect to the share from say VM8 with TCP as the transport. While it tries to connect from a different VM, we can attempt to access the share using QUIC. You see the QUIC, using QUIC as a transport, we can immediately make a connection, whereas the transport TCP, it fails to connect because obviously TCP/445 is blocked on the server. And it takes a while because it tries to make retry attempts until all of the number of retry attempts have reached the limit. There you see it has reached the limit, and so it still couldn't successfully make the connection. A small timeout of 30 seconds just to make sure that we flush off any negative cache from the redirector state, and this time we will try to connect to the same shared resource using QUIC as a transport. There you go. See, it readily connects. Trying to see some contents from the shared resource. So here is a directory that has 1,000 directories and 1,000 files plus a 1 GB file, and we are able to list all the contents. Yes, you see the 1 GB file as well. So that's pretty much it. And if you want to know more details about this feature and more information about the release, you can contact nedpile@microsoft.com, who is our principal PM for this feature, and he will he'll be very helpful. Thank you. We'll take Q&A later since this is only a recording session. And thank you all. Thanks, Thomas.